Hello, everyone, and welcome to the next session. I have Robin here, another one of our core developers from Parity. He's going to be talking about Inc 3.0, a Rust and smart contract love story. I'll let you take it from here, Robin.
Thank you, Caroline. Hello and welcome to my talk about Inc 3.0, a Rust and smart contracts love story. First of all, I'm going to use the full 20 minutes, I assume. So questions and answers, please. After the talk, go to the Discord or Element channels. They are bridged, so just join one of them and you're fine. First of all, what is Inc? Inc is an embedded domain-specific language for the Rust programming language to create WebAssembly smart contracts targeting substrate-based blockchains. There are three questions now. Why Rust? Why WebAssembly? And what does it mean to be based on Substrate? By the way, this is our mascot. It's called Squink, and it will guide us a little bit through the presentation. So first of all, why Rust? First of all, it has a minimal runtime, means we are going to expect no overhead or can strip away a lot of overhead, resulting in very minimal WebAssembly binaries. Rust features zero-cost abstractions and also safe abstractions and building blocks, means we can produce our WebAssembly smart contracts safely and efficiently. It comes with its cargo and creates our ecosystem, meaning we are very productive while working on our smart contracts. And also it features first-class WebAssembly support. Rust has been the most loved language for the past 5 years, even with a huge margin, according to the Stack Overflow Developer Survey. And also its usage increases like significantly over the last years. So expect to be more Rust in the future. Next question is, why are we using WebAssembly? So it's a general virtual machine and specifies general virtual bytecode. It was initially and also designed for very efficient JIT execution, meaning our smart contracts are just fast. Its formal specification fits on a single page. This is very important if we are talking in the future about verification of WebAssembly smart contracts. And also it allows for being executed deterministically. This is especially important and one of the most important points for blockchain systems, where many nodes have to agree on the same result. And also we prefer open standards over custom solutions. But what does it mean to be based on Substrate? In Substrate, we provide you with the contracts palette, and every Substrate chain that includes this contract palette also supports Inc to some extent. The contracts palette simply orchestrates the execution of WebAssembly smart contracts, but is not limited to Inc. It is allowing for WebAssembly smart contracts. This allows for alternatives. One alternative is the Solang Solidity to WebAssembly compiler, developed by Hyperledger Labs, funded by the Web3 Foundation. So the design principles of Inc are Solidity, the good parts. So there are many bad parts in Solidity. We only take the good parts, but Solidity is still a solid language that many people know and many people are very accustomed to. And on the other hand side, we want Inc to be just Rust and feel like Rust. So if you know Rust very well and feel very comfortable in writing Rust, you should also be feeling very comfortable to write Inc. And on top of that, we really try to make its code generation very solid. So it's just a thin, solid layer on top of bare metal. In our next chapter, we are going to show you a little bit how Inc looks and feels based on an ERC20 example contract. This is a very simple exemplary contract that has accounts for users, and you can very simply and easily transfer balance between those accounts. So the general structure of an Inc smart contract first has an import line. We do this for convenience. And in Rust, you have modules that with which you can structure your source code. And in Inc, you initialize a contract or telling Inc to, hey, here's our smart contract, by annotating such one of those modules with Inc : contract. This tells the Inc compiler, hey, everything inside this module is Inc code. But not only Inc code, so everything in this entire file is still Rust code. So also within this module of Inc, you can still specify Rust code just as you would everywhere else. But within this module section, you can specify ink entities. What are those ink entities? So first of all, we have the ink storage struct, which defines how the contract storage is laid out. In our ERC20 contract example, we have on the one hand side a total supply field that is of type balance, and we have a balances field that is a mapping from account ID to balance. So every account ID can have one balance. Yeah, that's basically everything and all to it. Every ink contract needs at least one constructor, meaning we can have multiple. But for our purposes, we just define one of them now. It has a name new, and it takes an initial supply of type balance and returns self. Self is what is in other languages, for example, this, and just means that it returns an ERC20 contract. And I'll quickly go through its implementation, go just a little bit into detail to explain what happens there. First of all, we receive the caller through self::env. This makes it possible to interact with the environment between ink and the contracts palette. And the contracts palette allows us to retrieve the caller from that. And next, we instantiate our balances hash map and insert the initial supply to the caller. So the caller receives the entire fundings for the initial round. And in the end, finally, we just construct our ERC20 contract just as we would construct any other Rust resource. So nothing special here. The only thing that is not standard Rust is this small annotation on the top. So on the next, we are specifying one of the two messages for our ERC20 contract. It's called the total supply, which just returns the total supply that we initially specified. And it's more or less a getter. So the ampersand self means that this message will never modify our storage. It's very similar to a view function in Solidity. And next, we'll see a transfer message. Here you can see that it has ampersand mute self, meaning that it may mutate storage. And it also features two argument type account ID and an amount of balance. And it also returns a result, meaning that it can also fail. So either it returns okay, then everything is fine and the transfer was fine, or it returns an error, for example, in case the caller doesn't have sufficient funds to actually do the transfer. There are also event definitions. For example, we can have a transferred event for our ERC20 contract that looks roughly like this. So we can have from source, we can have to source, where from is sending some amount of balance to the to account. Those are optional. We'll see in the next slide why. And those are ink topic annotated. This is very similar to what Solidity indexed arguments are for events. And this is the constructor from 2 slides before that we just went through. And now I'm showing you how we would emit an event from this. So this is the event definition with the 3 arguments so that you can keep it in mind. And one thing we would change is we again would access the environment through self::env, and then we would specify a emit event and construct our transferred event, giving it a none for the from, because the initial fundings come from nowhere. The to is specified as our caller, and the amount is simply the initial supply. And for the message, we can also emit events. This is done very similarly. So here the self is small, and we do not have : but simply a dot. But the rest is pretty much the same. So you still have from, to, an amount. And that's basically it. So there's nothing more to add to that. So you might ask, if you've seen the last ink demonstration of 2.1, what is the big deal? Because everything I've showed you so far is also available for ink 2.1. So let's dive into the new parts and the cool stuff. So you have to know ink 3.0 is basically a rewrite of the whole system. Why is that? Ink 1.0 was a prototype where we answered the question, is it possible? Ink 2.1 is, how can we make it beautiful? And Ink 3 is, how can we make it good? So For the new code gen is we have the flipper. Flipper is more or less the hello world. We do not go into the detail here. It's just a hello world contract featuring two messages and one constructor. The constructor taking a bool and initializes some Boolean value. It doesn't have any more than that. Flips the value from true to false or false to true, and get returns the current value. And for Inc.1, this contract resulted in 12 to 16 kilobytes of WebAssembly. For Inc. 2.1, the same contract resulted in 4.5 kilobytes. So we already significantly reduced the amount. And Inc. 3 reduces it to another 1.2 or 1.4 kilobytes. So you might ask, why are these two numbers and why not one number? The difference is in the following. The Inc. 2.1 is doing less than Inc. 3.0. And to make both equivalent, we have to add the payable annotation to flip and get, making both messages avoid and omit certain checks up front. And this results in 1.2 kilobyte of WebAssembly. For the next, I want to talk a little bit about the storage of Inc. smart contracts. And this is the big picture. So on the one hand side, we have the contract that is communicating with the pallets, contracts pallet over a well-specified API. And on the contracts pallet side, it has access on the storage database. So any access to the storage is always through the contracts pallet. On the Inc. side, we have the so-called memory that we also conveniently call the cache because it's faster than storage. And whenever we do a computation, we first of all pull the storage that is immediately required for any execution of the smart contract. Then we compute our contract storage. Then we compute our messages or constructors, etc. And we try to stay as much as we can within our cache and only load from storage very lazily, only when we really need to. And in the end, we push the storage back to the storage. All of this is hidden from the user. The user doesn't need to care at all about anything of these details, and everything is managed by Inc. basically. But let's take a little bit of a look into the storage database and what it entails to the users. So if we unfold the database, we see that it is more or less a linear table of so-called cells, storage cells. And these cells are indexed by 256 bit keys and contain values that are of any byte sequence. So a cell can have 0 bytes, 1 byte, a bazillion bytes, it doesn't care. So if we, for example, want to store a vector in one of those storage cells, we can either do this in a packed layout, where we store the entire vector that could potentially consist of thousands of elements into a single cell. And if we add another element, we obviously would also encode this into a single cell, and so on. But this obviously breaks as soon as we want to only manipulate single elements of our vector while the vector is very large, like consider 10,000s of elements. And we only want to manipulate one element. We always have to encode and decode the entire vector, which is immensely compute intense. So what we would do instead is we would use a spreading layout where we spread every element into its own cell and store a length into yet another cell. This means that if we, for example, push another element, we would simply use another cell, etc. Obviously, this breaks when we want to, or does not scale when we want to manipulate all cells at the same time, which is probably not a common operation for smart contracts, but it might happen in some use cases. So it also breaks. Our solution, or what we could do, is we could, for example, go for a trade-off. Hey, let's pack every 2 elements together, and so the vector is only half of the size. And the Inc. storage crate that is new allows for all these use cases without any custom code. You just have to use the types and the data structures that it provides. And it provides tons of those. And it will provide even more in the future. So you are complete. It's like the standard library of WebAssembly smart contracts for Inc. And there's one very big feature left that I wanted to demonstrate to you. It's called trade support. And in the following, I want to show you why we need traits. Traits are very important, especially also for designing systems such as smart contracts. So you define one trait that is, you can compare it like a base class or an interface. So that can be shared by many concrete WebAssembly contracts as interface. And this is depicted by this graphic. So we have, for example, we have one ERC20 base interface and many concrete implementers of those. How would this look like in Ink? First of all, we see that we have a normal Rust trait definition marked with an Ink trait definition annotation. Everything else is pretty similar, besides that the messages do no longer have an implementation block. So we are just looking at more or less a Rust trait in definition. And how would you implement these for your smart contract? Let's look at our current ERC20 implementation without trait support. And now let's add trait support to it. Done. So we basically added base ERC24. That's it, with the previous implementation, of course. And how would we call it? We would basically call it using this code. We would first import our trait, then we would instantiate our ERC20, and we would just be able to use the methods as usual. But since it's a trait, we could also use universal function call syntax. That's a concept very well known to Rust programmers, and call these methods from that kind of syntax. So our contract, therefore, just implements normal traits. And while this new design is very limited at the moment, we will definitely try to resolve some of those current limitations and make it an even more useful feature in the future. Another thing that really improved over the last months is our tooling story. So as you might know, we have the Cargo Contract CLI tool. That is the more or less official build tool for Ink. And it comes with 3 new comments with which you can, via CLI, deploy, instantiate, and call Ink smart contracts to an on-chain. How would this look like for a Flipper contract that we discussed previously? First of all, we could just deploy it like this, retrieving a code hash that I marked as blue. We would deploy from Alice. Then we can instantiate this exact code hash as a new contract instance and would retrieve an account for the contract. And then we can simply call it via RPC and return a result that is immediately true because we instantiated the Flipper account with true. Then we would flip it, for example, and immediately expect it to be false later. So this works, but it's brand new, so expect there to be a little bit chaos if you're using it right now. And one last thing is we also developed a completely brand new UI specialized for contracts. So until now, you more or less used the very generic and powerful Polkadot.js apps, but now we have a new Canvas UI that is targeting Ink, or more or less Ink and Solang contracts. It's available through this domain URL. So just you click it into a browser and try it out. And this picture just shows how you can upload a new ERC20, obviously one that is a little bit more feature complete than what we just demonstrated. And this is how we would deploy it, for example, with a certain endowment, showing us the block time that it would take with the new and the parameter. And we can also execute it. Here we just execute the total supply and we receive instant feedback. And this is how it overall looks like. And if you look into this very tiny corner, you might see a Canvas test. So very, very, very recently, we just deployed a test network for contracts that you can immediately try out. The link below is for the telemetry. And we also deployed a faucet that is available through the matrix link below. But expect chaos. It is so brand new, just expect chaos. And within chaos, expect more chaos. And with that, I want to remind you of our workshop, of our Ink workshop later today, where we'll go much more into the details of Ink and we'll explore even more. We'll answer all of your questions there. And please go to the Discord element channels and ask questions until then, or go to the GitHub page for our Ink project if you have bug reports, etc. Like Ink 3.0 is currently released as a release candidate, so there might be bugs. In the end, this is not the end of this love story, but certainly the end of this presentation. Thank you.
Thank you so much, Robin. That was great. Yeah, unfortunately, our time is up, so we don't have time to answer those questions that have been submitted. But please go over to Discord, just as Robin mentioned, or onto Element to further connect with Robin and the rest of the team on any questions you have about Ink. Great. So we'll go into our next session now. So see you in there.
See ya.